Hello. Our objective today is that we are going to determine rates of change in applied settings. These mean word problems using known formula. Um, Typically, this topic is called related rates. So in our first example, we have a car is traveling north towards an intersection. So it's going in this direction at a rate of 60 miles per hour, while a truck is traveling east away from the intersection. So it's going that way at a rate of 50 miles an hour. Find the rate of change of the distance between the car and the truck when the car is 3 miles south of the intersection and the truck is 4 miles east. So we start these problems by looking for a geometric formula that seems to be describing this relationship. This one is a right triangle, and we're talking about the relative distances. So you can probably guess we're talking about the Pythagorean theorem. A squared plus b squared equals c squared. It doesn't really matter which is a and which is b, so I'm just going to make up which I want to be a and b, and then we're going to put a c right there as well. So a, b, and c. And whenever we do these, the first step is always going to be to take the derivative of whatever function that is. Now, you can have it memorized because it's always the same, or you can figure it out for yourself each time. But you do need to know it, and you need to write it down. So the derivative of a squared is going to be 2a times dA dt because of the chain rule. The derivative of b squared would be 2b times dB dt. And then the derivative of c squared would be 2c times dc dt. So what we just wrote down is Pythagorean theorem derived. It will always be this, so you can, again, memorize it if you want, or come up with it on your own if you want. The next step is to list out all the possible things, all the possible variables and what they might be. So we have a and dA dt. Sorry for my handwriting. We have b and dB dt. And we have c and dc dt. So a, b, and c are distances, and a, dA dt, dB dt, and dc dt are how those distances are changing. These are rates. This is why it's called related rates. So let's see what they gave us. They say the car is traveling north toward an intersection at a rate of 60 miles per hour. So that means that this arrow that I initially drew in red, that is going towards the origin or the intersection at a rate of 60 miles per hour. So dA dt is how a is changing. That's going to be negative 60. And I said negative because this distance is getting smaller. So dA dt, negative 60. Then they said that the truck is traveling away at a rate of 50 miles per hour. So this is going to be how d is changing. So this is dB dt. And this is positive 50 because the distance of b is getting bigger in this case. Then they asked for the rate of change of the distance between the car and the truck. So the distance between the car and the truck is c. They're asking the rate of change of that distance. So what they're asking for is dc dt, which means we're probably going to need to have everything else. They also told us that the car is 3 miles south of the intersection, so that's just exactly 3, so we know that this is 3. The truck is 4 miles east of the intersection, so that this is 4. They did not tell us what C is, but there's probably two ways you might know it. One is that this is a 3, 4, 5 triangle, so C is 5. The other way is, if you really didn't know that, you could just go here and say, well, 3 squared plus 4 squared equals C squared, and solve for C. That's also going to get you C equals 5. I'm not going to show the work for that right now. What this now means, though, is that we can finish this problem. Going back to this, sorry, that was just meant to be a line. I'm going to plug in all these values. So 2 times A is 2 times 3, times dA dt is negative 60, plus 2 times B, B is 4, and dB dt is positive 50, equals 2 times C, which is 5, times dC dt, which is what they asked for. There should always be just a single variable that you're still looking for here. So I've got my calculator handy. 2 times 3 times negative 60 plus 2 times 4 times positive 50. The entire left side of the equation comes out to 40 is equal to 10 times dc dt. This is kind of the easiest part here, is just once the numbers are plugged into solving. Last step is to divide by 10, so dc dt, the rate of change of the distance between the car and the truck, is 4. We're always going to want units, so let's see. The dA dt and dB dt were measured in miles per hour, so this would also be measured in miles per hour. All right, our next example, this is an actual AP problem. They say oil is leaking from a pipeline on the surface of the lake and forms an oil slick whose volume increases at a constant rate of 2,000 cubic centimeters per minute. The oil slick takes the form of a right circular cylinder with both its radius and its height changing with time. So, in case you didn't know it, they then gave you this formula. So we are, of course, going to need the formula volume is equal to pi r squared h. I know I haven't even read this yet, but bear with me. And then the derivative of this, again, you can either memorize it or figure it out for yourself. If you figure it out for yourself, this is a product rule. The derivative of this would be dv dt is equal to, I'll do the r first, so that would be 2 pi r dr dt h plus, now I'll do the h, this is pi r squared dh dt. Again, you can also just have this memorized, that's totally fine. At the instant when the radius of the, I guess I should start writing down what we need over here. So we've got we have v and we have dv dt. So that's the volume and how the volume is changing over time. We have a radius and how the radius is changing over time. And then we have a height and how the height is changing over time. So a total of 6 things that we could have. Obviously, they're going to ask for one of these. I'm going to go back because they gave us this earlier. They said that the volume is increasing at a constant rate of 2,000 cubic centimeters per minute. So that must be dV dt, how the volume is changing. Whoops, I wrote 1,000. That meant that was 2,000. Now let's go back to this. At the instant when the radius of the oil slick is 100 centimeters. So they said the radius is 100. So I know R. And the height is 0.5. So I know H. The radius is increasing at a rate of 2.5. So the radius's rate is 2.5 and instead increasing. So that's positive. And then they asked for what is the rate of change of the height of the cylinder with respect to time. So this is what we don't know. Now you notice they didn't give us the volume here. If you look at this formula that we're going to be using, that formula doesn't have a V in it, a capital V. So it looks like we don't need it. But if we did, we know the radius and the height, which is right here. So we could find the volume if we wanted to. So we don't need it here, but if we did, we could find it. They didn't need to give it to us. So I'm going to plug in all our numbers here. So dV dt is 2,000 is equal to 2 pi. The radius is 100. dr dt is 2.5. You know what? I forgot an h back there. I'm sorry. I'm not going to re-record this whole video, but product rule says derive this and then leave this part of it the same. So that should have been an h after that dr dt. I'm going to fix it right now. So 2 pi r dr dt and then h is 0.5 plus pi r squared, so that's 100 squared, times dh dt, which is what we're looking for. So as ugly as this is, there's really just 2 terms here. We've got this whole term that I'm going to simplify, and then we have this term, which I'm going to simplify, and then the 2,000 that's just hanging out on the left for right now. So this is 2,000, and then, let's see, I'm grabbing my calculator. This is going to be 2 times 100 times 2.5 times 0.5, which comes out to 250, and there's a pi there, of course. So this is 250 pi. And then plus 100 squared is 1, 2, 3, 4 zeros, so 10,000 pi dH dt. And it looks like there's 2 steps left to getting dH dt by itself. Subtract 250 pi and divide by 10,000 pi. So dH dt is equal to 2,000 minus 250 pi divided by 10,000 pi. I didn't show all the Algebra 1 steps in there, but you could if you find that helpful. It told me what the units were in case I didn't know. I could have figured this out myself because height is measured in centimeters, so this would be centimeters per minute because this was all in minutes. But they told me just in case. So this is in centimeters per minute. And that is the rate of change of the height of this cylinder.